Before we proceed to Major 2, let us start answering this question together. I will be fast. What I will need you to do, what I will need you to do is you need to pay attention how the things are done, not actually how the things are calculated, how the things are done. So, the first question for 5 marks, you are asked to determine if the following systems of equation is a unique solution, no solution, or infinitely many solutions. You must show all workings. So what you need to do first, you need to take out your matrix A. Before you do that, you need to analyze that this column here, we only have X. The second column, we only have Y. The third column, we only have Z. So that is the most important thing again. You always need to check that. So I'm going to take out your matrix A. Your matrix A, it's going to be 2. It's going to be 2. Not too much. The matrix A is going to be 2, 4, 3, negative 1, 2, 1, 7, 2, 3. That is matrix A. And matrix AB should be 2, 4, 3, negative 1, 2, 1, 7, 2, 3. And substitute this dash line to write an argumented matrix. So this is an argumented matrix, this one with AB, because it's the one is with that line. Right. Another thing that you need to do, you need to find the determinant of both of these matrices. So finding the determinant, it's not something that is very hard, that most of you can do. So the determinant of A, it's going to be 2, 2, 1, 2, 3, plus 1, 4, 3, 2, 3, plus 7, 4, 2, 3, 1. So calculate that. What do you get? 2 minus 1, 7, 4, 2, 2, 3, 1, 3. I'm just using my calculator to find the determinant. You can also do that. You are allowed to do that. The determinant will be what? Will be 0. Right. Since the determinant is 0, we need to find another submatrix here that will give us what is this? That will give us a matrix in A, any matrix in A that will give us a determinant. I will choose that one. Now, if I choose that one, I'm going to say it's A1, which is 4, 3, 2, 1. So the determinant of A1, it's going to be 4 times 1 minus 6, which is negative 2, right? So we got the determinant on A1, which is what? Which is minus 2. This determinant of A1 is found where? It is found on A, which means the rank of A, it is 2, because we got the determinant of A at a 2 by 2 matrix. So that's why we said the rank is 2. Right. The next thing that you need to do, we need to find the determinant of matrix AB. What I'm going to do to find the determinant of matrix AB, I'm going to take this column. And place it there. And then I'll calculate the determinant. So let us have AB, which is a matrix of 2, 5, 1. Minus 1, 2, 1, 7, 2, 3. Now let's find the determinant of this. The determinant of AB, it's going to be 2, 2, 1, 2, 3, plus 1, 5, 1, 2, 3, plus 7, 5, 1, 2, 1. So what is the determinant of AB? Right, let us look at the determinant of AB. So it is 2, negative 1, 7, 5, 2, it's 5, 5, 2, 2, 1, 1, 3. So what is the determinant of this matrix? It is 42. Our determinant here is just 42. So the determinant of AB, it is 42. Right. So if the determinant of AB is 42, we would say that the rank, the rank of AB is equals to 3. Why the rank of AB is equals to 3? Because we got the determinant as 42 and the matrix A is a 3 by 3. How many equations do we have? We have 3 equations there. Alright, so since we have 3 equations, what we are going to do, we are going to say the rank of A, it is less than the rank of AB, right? Since the rank A is 2 and the rank of AB is that, and UN is equals to 3. In this case we have, no solution. We have no solution here. Since ama rank akangalingani. Another thing that I'm going to do, I'm just going to check it in a calculator, because my calculator can handle these things very easily, but let me check what you can do it in a calculator. Yes or no? Yes, we have no solution in this case. I can even show you, but I will not show you. Here we have no solution, right? So since we have no solution, we will get our full 5 marks, like that. Let us move on. Number 2, solve the following system of first order differential equation using the matrix method. To solve this, first we need to write our matrix A. Matrix A is the coefficients of that, so it's going to be 1, 4, 1, 1. And again, this column here, you have x1, and this column is for x2 to write that matrix. Right, we need to solve that. And then we have subject to the initial conditions of x sub 1 is 0 and x sub 2, x sub 1 is 0, it is 2, and x sub 2 of 0, it's -1. So to solve this system, the idea is very simple. Find the eigenvalues of that matrix. You are done. Because since this is the first order, the solution of this is going to be x is equals to a v e to the power lambda 1 t. This is v1 t plus b v2 e to the power lambda 2 t, like that. So I think you'll have something like that. So this must be your solution, by the way. So we need to find the determinant of a minus lambda I2 is equals to 0, which is the same thing as the determinant of 1 minus lambda for 1 minus lambda is equals to 0. If you substitute, if you are trying to solve for lambda here, I'm going to have 1 minus lambda times 1 minus lambda minus 4 is equals to 0. You will have lambda squared minus 2 lambda, and then 1 minus 4, that is minus 3, plus minus plus, so it's minus 3 is equals to 0. So if you factorize this, your lambda plus 3, your lambda minus 1 is equals to 0. So your lambda 1, it's actually going to be minus 3, and your lambda 2, it is 1. In this case, what you are going to do next, we are going to find the eigenvectors of each of these lambdas. So first, I'm done with the first step. Find the eigenvalues. Right. The second step here is to find the eigenvectors. So for lambda 1, which is negative 3. What are the eigenvectors of this? I'm going to take this 3, that's negative 3, and then I'm going to substitute it back there. If you do so, I am going to have 1, which is going to be 4, 4, 1, 1, yeah, it's 4, 4 over 4, and then 1 minus, yes, it is 4, 1, 4, 4, which we have x1 and x2 is equals to 0. Now, this thing does not make any sense, really. Do we have minus 3? Did I factorize correctly? Because you cannot have something like that. It is 1 minus 2, right? Minus 2, and then minus 3, because minus 3. X is positive 3. Oh, x is positive 3, guys, and x is minus 1. I did factorize wrong, incorrect. Sorry. So we have a minus 3, we have a positive. Now I see that you have a negative sign. So if you substitute a positive 3, now everything will change here. Now this is the thing about these eigenvalues. You'll see that it does not make any sense. So if you substitute a positive 3, lapana, we are going to have 1 minus 3, which is negative 2 and 4, and then 1, and then 1 minus 3, 1 minus 3, it is negative 2. Times x1, x2 is equals to 0, 0. Now here we are going to say let your x2 to be alpha. If you say let x2 is equals to alpha, you take this 4, you multiply it lapana, this you multiply it there. So you are going to have 4x1 minus 2 alpha is equals to 0, and then x1 is equals to. So I'm going to have negative 2 divided by 4, which is going to be 1 over 2 alpha, like that. So we have it in that way. So if in that case you're going to have v1 here is equals to 1 over 2 alpha and alpha. Remember that we take out on your thing, we will take out the highest common factor of a fraction in your vector. So it's going to be 1 over 2 alpha, which is 1 and 2, right? So this is your eigenvector. And then for lambda 2 is equals to negative 1. If you substitute a negative 1 there, I am going to have a 2, 4, 1, 2 times x1, x2 is equals to 0, 0. And we are going to say let beta to be alpha. If we let beta to be alpha, we are going to take any of the equations here and multiply. So I'm going to say 2x1 plus alpha. Let x2 to be beta like that, and then your x1 is going to be negative 1 over 2 beta. So in this case, we are going to have v2, which is negative 1 over 2 beta, and then your v2, it is negative 1 over 2 beta, which is 1 and negative 2. I think everything is correct. And then what we are going to do next, we are going to substitute it back to this equation. And if you do that, I'm going to have x1 of t, x2 of t is equals to your a, what is your v1? It is 1, 2, e to the power 3t plus b, which is 1, negative 2, e to the power negative t. which is the same thing as x1 of t. It is a e to the power 3t plus b e to the power negative t. And then x2 of t, it is 2a e to the power 3t minus 2b e to the power negative t. Right. The next thing that we are going to do, we need to substitute these initial conditions. To do the initial condition step, let us solve the initial conditions. So the first one, when you substitute 0 on x1, I'm going to get a plus b is equals to 2. If you substitute 0 on x2, I'm going to have 2a minus 2b is equals to minus 1, like that. So you're going to solve it using your own method, by the way. So if I multiply the first equation by 2, I'm going to have 4a is equals to 4 minus 1, which is going to be 3. So your a is going to be 3 over 2. If a is going to be 3 over 2, what would be the value of b? So it's going to be 2 minus 0.75, which is going to be 4 over 5. 4 over 5. So what I am going to have here next is your final answer. Your x1 of t, it is, what is a? 3 over 2 e to the power 3t. What is b? Plus 4 over 5 e to the power negative t. And then your x2 of t, it is 3 e to the power 3t. The second one is negative 2b, so it's going to be negative 8 over 5 e to the power negative t. So this is your final answer, if you are going to do it correctly. Right. The third one, we are asking to find M and S are the nodal and spectral matrices respectively of A. Prove that. So how do you prove that? It's very, very easy to prove it. We are going to say A times M. Now you know that M, it is a modal matrix, and then S, it is the spectral matrix, right? The modal matrix is a matrix of eigenvectors, and your spectral matrix is a matrix of eigenvalues. So it does not matter really. So what you're going to do next, you're going to prove it in this method, right? So I'm going to say A times x1, comma, x2, comma, x3, comma, and then x to the power n, like that. And then the next thing that I'm going to do, I'm going to multiply a in bracket, so it's going to be am is equals to ax1, comma, ax2, comma, ax3, comma, dot dot, axn, like that. Now what you remember is that whenever you multiply a matrix with an eigenvector, what will you get? You will get an eigenvalue times an eigenvector, right? So A times n, it is the same thing as lambda 1 x1, eigenvalue times eigenvector, times lambda 2 x2, comma, lambda 3 x3, comma, dot dot, lambda n x, like that. So it is in this way. So the first part is done. The second part, what you're going to do, I'm going to say m times s, right? M times s. So your m times s is going to be x1, comma, x2, comma, x3, comma, dot dot dot, xn, like that, times s. And then this is an eigenvalue, which is s. So if you say s times x1, comma, s times x2, comma, s times x3, comma, s times xn, I'm still going to get what? lambda 1 x1, because s is the eigenvalue, so x lambda 3 x3 comma lambda 4 lambda n xn, like that. In this case, you can see that both of them, they are true. Now, if both of them, they are true, where's the matrix of this one? If both of them, they are true, we are going to say that A times M is equals to M times S. How would you move an M on that side? I'm going to multiply both sides by the inverse of M. So I'm going to have M to the power minus 1 times A times M is equals to M times M to the power minus 1 times S. Now, when you multiply a matrix by its own inverse, you are going to get an identity matrix. So it's M to the power minus 1 times A times M is equals to AN times S. Now, an identity matrix times a matrix, you're always going to get a matrix times M, which is going to be S. So it is a proof. So for 5 marks, this proof is nothing. Right. Now we are starting to do the calculus part. Question 4. Evaluate the double integral in region D of 10x squared y cubed minus 60a, where D is a region bounded by x to the power minus x is equal to minus 2x squared and y is equal to x cubed. The first thing that you need to do, you need to rewrite your integral 10x squared y cubed minus 6 d. The next thing that you need to do, you need to draw your region. How will you draw a region? The first one, x is equals to the cube root of x is equals to the cube root. If you say x is equals to y cubed like that, y is the same thing as the cube root of x. Y is the cube root of x. Right? So you understand that part. And then if we say x is equals to negative 2y squared, your y is actually going to be the square root of negative 1 over 2x. Like that. So what are you going to get on that? Since x is the subject of the formula, I'm trying to think, because I know this one, that one, it is something like that. So y is equal to the cube root of x is something like that. X is equal to minus 2x squared. If you substitute positive values of x, you're always going to get, if you substitute positive values of y, you're always going to get, it's something like this. Now I see the diagram. Yeah, I know sometimes it is hard to draw these, but you gotta trust yourself in these. Because you need to look at this. Now, for x is equal to minus 2x squared. If you substitute a value of y, which is going to be positive, I'm going to get a value of x, which is negative. Actually, your values of x here will always be negative. So that graph, it is something like that. And the graph for x cubed also, it is something like that. So like that. So it's something like that. So they intersect there, they intersect there. This one was the hard one. So to do it, let us just solve for x. X is equal to that, so y cubed plus 2y squared is equal to 0. Take out the highest common factor of y squared. I'm going to have y plus 2 is equal to 0. So y is either 0 or y is either minus 2. So there I'm going to have a particular negative 2, there it is 0 is to 0. 0 is to 0. Now if you substitute y cubed as x, so I'm going to have a negative 8 there. So your region, it is this part here, the shaded thing. Now what type is this? I don't care, you can do it with type 1 or type 2. But let us do it. Let's y and let's x now. To make things simple. To make these things very simple, we'll just do that. So if you do it, x wako, y wako uzoqala kubani? Y wako uzoqala from negative 2 to 0. X wako uzoqala kubani? X wako uzoqala graph emnyama. Is this black graph? You see this black one there, which is what? Y, which is negative 2 y squared and still up on y cubed. Like that. So now you can integrate. If you do so, negative 2 to 0. What is the integral of this in terms of x? I'm going to have 10 over 3 x cubed y cubed minus 6 x between negative 2y squared and y cubed. If you do the math correctly, negative 2 to 0, 10 over 3, x is y cubed, so y cubed, y to the power 9, y to the power 9 plus 3 plus 9, it is 12, so I'm going to have y to the power 12 minus 6y cubed plus, it's going to be plus 20 over 3, I've just substituted y to the power 6 plus 3, it's going to be y to the power 9. If you substitute over a positive, it's minus 12y squared. And then you can just do this one using a calculator. Actually, your prof does not care when he comes at that first part. The most important thing here, it is the thingy. What is this? The substitution, the order. If you know how to set up, everything is nice. To the power 2. Now between negative 2 and 0. Let us wait for my calculator. It's saying 18328 divided by 13, which is the same thing as 1409.85. That is an approximation. So it's something like that. Question 5. Change the order of integration the following integrals. So what you need to do there, first you need to take out those functions. So the first one, it's going to be x is equals to 0. The second one, it is x is equals to 4a. Second one, y is equals to 1 over 4a x squared. Then y is equals to 2 root ax. Like that. So if you draw the region, The question said no marks would be awarded if the change of order is not done. Right, so that is a key thing that you need to understand again there. No marks will be not awarded. Sometimes the prof may say do not evaluate the integral. So just leave it like that. So we have that. So we have 2 times. So it's a graph like that, and then a graph like that. So they meet at this point. So the region that I'm talking about, it is this one here. Right. Now these coordinates there, it is 0 is to 0. If you substitute a point of 0 there, I'm going to get that. If you substitute the point of x, I'm going to get 4a. 4a is to 4a there. So it's 4a is to 4a. In this case, now let us evaluate. So it's going to be dx dy. Your y will start from 0 to 4a. Your x will start from this graph in terms of x. So we need to rewrite that graph in terms of x. So if we do that, I'm going to have y squared. I'm going to have x is equals to 1 over 4 a x squared. Right, so it's going to be 1 over 4 a x squared. And the top one, just hate it when they do it in this way. X is equals to the square root of 2ax. So it's the same thing, by the way. It's ax, it's the same thing. So now let us calculate. 0 to 4a. What is an integral of that in terms of x? It's going to be x between 1 over 4a x squared to 2. You need to have y's there. Y's. Sorry guys, you have y's there. Y's. So it's 2 root a1 dy. Integral from 0 to 4a, 2 square root ay minus 1 over 4a y squared dy. So what is the integral of this? 2 root a times 1 over 0.5 plus 1. It's going to be 2 over 3 y to the power 3 over 2. If you substitute it correctly, minus 1 over 4a times 1 over 3 y cubed between 0 and 4. So I'm going to get 4 over 3 root a times 4a to the power 3 over 2 minus 1 over 12a times 4a cubed. So actually you are going, this is the final answer. This is your final answer because we can simplify it by the way. 4 over 3 plus root 4 cubed, which is 28 over 3 root 8 minus 4 cubed divided by 12. 4 cubed divided by 12, it's going to be minus 16 over 3a cubed. So this is your final answer here. Question 6. On question 6, express The integral df of xy dA as an literal integral in polar coordinate, where f of x comma y is equals to 1 over 1 plus x squared plus y squared, and D is the region in the first quadrant inside the cycle with center 0 is to 0 and radius 1 is to 1, and center and the radius 1, and center 1 is to 1 with radius 1 to 1 respectively. So easy. So let us draw that region. Since it's on the first quadrant, it is this part for the cycle, and second part it is that part of the cycle. So it's a circle, it's secular. So you R from the origin, start from this graph to that graph. Right? So the first graph, it is x squared plus y squared is equals to 1 with the radius, right? Good. The second one, it is x minus 1 all squared plus y minus 1 all squared is equals to 1. Again, but the problem that you are going to have here, we cannot express this in terms, we cannot just say it's R, because we know here that x squared plus y squared is equals to r squared, right? Which means r squared is equals to 1, so r is 1. So the outermost function has the radius of r is equals to 1. It is this part that you do not know. So how will we know? We need to simplify this thing. Simplifying it, I'm going to have x squared minus 2x plus 1 plus y squared minus 2y plus 1 is equals to 1. Collect like terms. We know that x squared plus y squared minus 2x plus y can be written in this manner. They can be written in this manner. So, we know that r squared, x squared plus y squared is r squared. So I'm going to have r squared minus 2 times r in bracket cos theta plus the sine of theta is equals to 1 plus 1, that is a 1, which is 1 minus 2, which is minus 2. It's minus 1, like that. Now we need to solve for r here. To solve for r, just complete a square here. How will you complete a square? You're going to say r minus, multiply this term by half. If you do that, I am going to have by half, anything that is not r there is just a constant. So in bracket, cos theta plus the sine of theta, all squared. Like that is equals to cos theta plus sine theta squared minus, because if you do, you're going to subtract, what's on the other side is going to be positive. So that's why I'm going to have something like that. Now square root, take the square root. So r is equals to the cos of theta plus the sine of theta plus the square root of cos theta plus the sine theta squared minus 1. So this is your value of r. This r here, it is represented by that expression. Right, so the double integral will be what is your value of theta? This is another problem that you do not know. Your value of theta, I think, is starting from 0 to pi over 2. Yes, your theta would start from 0 to pi over 2. Yes, your region starts here to there. So it's from 0 to pi over 2. So it's from 0 to pi over 2. And your theta, the minimum value of theta is that of r. It's going to be cos of theta plus the sine of theta plus the square root of cos theta plus the sine of theta squared minus 1. And the maximum value of r, it is just 1 over 1 plus r squared r dr d theta. So I hope that you can do that. And you actually can do it. I know. The question said, do not evaluate the integral. So the more marks were given here in this step. Marks were given in this step. So this is your final answer. Question 7. Convert to cylindrical coordinate and evaluate the triple integral. So the triple integral of x squared y squared to the power 3 over 2 dv. So x squared y squared is the same thing as r squared to the power of 3 over 2 times r dz dr d theta, like that. Right? So we have that. Now we are told that where S is a solid bounded by the paraboloid, Z is equals to 1 over 2x squared plus y squared, and below by the xy plane, and literally by the cylinder. So what we have here, if you have a 3D thingy, you have your paraboloid, right? That paraboloid of yes. We have a paraboloid that is facing upwards, and then we have a cylinder. And in your base, everything, it is bounded by an xy plane. A cylinder will do something like that. So we have a picture like that. So the region is in a high region, but the region is semi-trillion. It's a region. So this part is not anything anymore. So it's going to be an integral of r to the power r, and be r squared all to the power 3 over 2, right? 3 over 2 times r dz dr d theta. Now, what is your values of r? Your values of r will start from where? Your x value, the value of z, the minimum value of z is going to be 0 because it's bounded by the xy plane, right? What is the second thing? The maximum value. Your maximum value of z. You see this cylinder. This cylinder is equals to this paraboloid at the top. So if you take this x squared and y squared and substitute it there, I'm going to have 1 over 2 to be a 4, which is 2, which means your maximum value of z, it's going to be 2, like that. And then your r will be bounded by this cylinder here. Your r will be bounded by that cylinder. So this cylinder has a radius of what? Of 2, which means it's from 0 to 2. And the theta is from 0 to 2 pi. You see, very easy. I don't understand why people say these things are very difficult, because it's very easy. And again, 0 to 2 pi d theta times 0 to 2 r to the power 4 dr times 0 to 2 dz. The answer here, I'm going to get 2 pi times 4 between 0 and 2. If you integrate that, I'm going to have 32 over 5. So it's going to be 32 over 5 times 2. So 4 times 32, what do you get? Times 4, it's got 128 over 5, so 128 over 5 pi. That is the final answer. Right? Let us look at number 8. Your number 8 will be evaluate the triple integral where it's a region inside the sphere of that and the cone, like that. So there is a sphere and the cone, and then this cone is facing downwards. How did I say the cone is facing downwards? Because there is a negative in front. So like that, and then if you draw a cone in such a way, and then this thing here, this thing there, which is something like that, your cone will be like that. So your cone will be something like that. So your sphere, by the way. So what do you need to understand? That this part here, it is your cone, and then this part here, it is a sphere. This, because they are saying inside we want this part here. So your integral will be x squared. Wow. What is x in spherical coordinate? I just forgot. Let me just set it up. I forgot the x. X in coordinate. What is the x in spherical coordinate? It is rho cos theta cos phi. So I have an integral which is going to be rho squared sine squared theta times cos squared phi times d rho sine phi d rho d phi d theta. Now between what coordinate? What is your rho? Your rho will start from 0 to 6. What is your theta? Your theta will start from 0 to 2 pi. What is your maximum value of phi here? It is pi. And what is your maximum value or your minimum value of phi? Now since your cone is starting from this side to that z value, we are going to say z is equals to the negative 3 in bracket x squared plus y squared, and then phi value from the positive is going to be 1 over root 3. Now what is phi value 1 over root 3 in radians? So it's 1 over root 3. What is it? It's pi over 6. So that is pi over 6. Now, pi over 6 in the positive axis. Since we are talking about a cone that is facing downwards, we need to say pi minus pi over 6. What do we get? 5 pi over 6. So your minimum value is 5 pi over 6. Without doing a lot of work, I don't do this crazy work because I just understand the diagram. And then your theta, do we have a theta? Yes. We have an integral from 0 to 2 pi of of sine squared theta d theta. Integrate this alone. Now, some of you were asking me you can do it in a calculator. Let me just check it for you. You can do it in a calculator. Between 0 and 2 shift pi. Yes, you can do it. You calculate. If you do it in a calculator, just remember that you need to change this thing here to be. You can put this in a calculator, but if so, when you are writing here down, you need to change it to 1 over 2 in bracket 1 minus cos 2 theta. This is integratable. What do you get here? You get pi is your answer. Right. The second integral is the integral of phi. So you have an integral between 5 pi over 6 to pi of cos squared phi times sine phi d phi. What is the answer here? What you can notice is that you can take your substitution by saying let u to be cos. If you let u to be cos, you can calculate this thing. Because we will have a u square. We'll have a u square, right? So a negative u square, by the way, negative u square. So what is cos 5 shift pi over 6? What do you get here? I get negative root 3 over 2. And then, what is cos pi? It's negative 1. So, negative 1 minus root 3 over 2. So your final answer in this integral is going to be times negative 1. It's going to be 2 plus root 3 over 2. So this is your answer on this integral. You can check it by yourself. I do not care. The last integral is an integral from 0 to 6 of rho cubed. D rho. What is the answer there? So alpha x cubed between x cubed between 0 and 6. You'll get 300 and you'll get 324. That is your answer. So what you're going to do next, you'll multiply these answers. You are going to say pi times 324 times 2 plus root 3 over 2. This should be your final answer. And then question 9, it is the line integral. It is not part of your major test, so I'm not going to do it. But to do it, you need to first understand the line integrals and Green's theory. That's all. See you on the next video, guys.